Welcome to Sol Speaks, the Sol Group Safety Podcast. This is episode number 5. Today, we are talking about gases that can catch fire, such as hydrogen, liquid methane, and propane or LPG. We store them and transfer them every day into cylinders, tanks, and containers of all kinds. We will not be covering acetylene. It has rules of its own, and we will dedicate a separate episode to it. Let us start with one basic point. A flammable gas, on its own, does not burn. 3 things are needed together: the gas, the oxygen in the air, and an ignition source. The whole of our effort comes down to exactly this, keeping those 3 things apart, always, at every stage. Before we look at the individual gases, let us stop on 3 concepts, 3 simple concepts which explain many of the precautions taken during the storage and filling of flammable gases. The first one is the right mixture. A gas does not burn under all conditions. If there is too little gas or too little air, nothing happens. The problem is when the two are well mixed. Propane and methane catch fire easily. Hydrogen is even more dangerous. It burns in almost any condition. And remember, a small leak in a closed room can turn into a dangerous mixture very quickly. So even the smallest leak has to be stopped immediately. The second concept is ignition energy. When we think of an ignition source, we think of a flame or a cigarette. But the energy actually needed is far, far smaller. For propane and methane, we are talking about 1/4 of a millijoule. For hydrogen, about 1/20th of a millijoule. Numbers that mean nothing at all until you compare them with this. The static discharge you feel when you touch a car door handle releases a few tens of millijoules, 100 times more than what is needed. This is not a theoretical possibility, it is an ignition source, ready to go, right there on you. That is why earthing and anti-static clothing are not a detail. They are how we remove the most likely ignition source we have in the plant. The third concept is pressure rise. If a flammable mixture ignites in the open air, it burns and it radiates heat. But if it ignites in a confined space, a room, a duct, a pit, a vessel, then the pressure rises up to around 8 times the starting pressure, from 1 bar to about 8 bar in a fraction of a second. To understand what that means, an infill wall gives way at less than half a bar, a door at far less. That is why ventilation matters so much, and clear openings and unobstructed vents. We are not trying to prevent a fire, we are trying to prevent a fire from becoming an explosion. Now let us look at the hazardous properties gas by gas, because knowing what we are dealing with changes the way we work. Hydrogen is the most treacherous gas we handle. It has the widest flammable range of them all, and the lowest ignition energy of them all. That means that a static spark, the kind you neither see nor feel, is more than enough. Its flame in broad daylight is almost invisible, no smoke, no color. And hydrogen is extremely light. If it escapes, it rises and it collects under roofs, in canopies, in the high spots nobody ever looks at. One last detail, and it is not an obvious one. Hydrogen, when it expands, does not cool down like other gases. It heats up. That is why filling has to be done gradually, without sudden openings. Liquefied natural gas is a different story. It is methane, but at minus 162 degrees. The hazard here is twofold: flammability and extreme cold. Even brief contact with the liquid or with a cold pipe causes cold burns, and it makes unsuitable steels as brittle as glass. 1 liter of liquid evaporating produces around 600 times its volume as gas. And be careful. As soon as it has evaporated, that gas is cold and heavy, so it creeps along the ground and forms a white cloud that you can see. Only once it warms up does it become lighter than air and rise. And remember, the visible cloud is smaller than the actual flammable cloud. Propane and liquefied petroleum gases in general are heavier than air. Always. If they leak, they do not rise, they sink. They collect in pits, in ducts, in sumps, in drainage channels, and they stay there for a long time. And down there, the dangerous mixture forms fast. 1 liter of liquid produces more than 250 liters of gas. Propane is filled by weight, not by pressure. The filling ratio is a safety limit, not a commercial target. An overfilled cylinder, if it is warmed by the sun, can end up completely full of liquid, which cannot be compressed and can reach pressures the receptacle was never designed to withstand. Let us move on to the collective measures and the engineering provisions, what the plant does to protect you. Flammable gas filling areas are ATEX classified areas. This means that everything entering that area has to be suitable. Electrical equipment, lighting, tools. The tools are non-sparking. The floors have anti-static properties. Pipework, equipment and metal structures are equipotentially bonded. And the tube trailers have their own dedicated earthing device. On the lines there are non-return valves, flame arresters where the plant manual requires them, and emergency isolation systems. There are gas detectors set on the lower flammable limit with an alarm. There are fixed fire protection systems and water jets for cooling. There are the interlocks that prevent the trailer from moving accidentally while it is connected. None of this works if somebody overrides it, bypasses it, or ignores it. Now the personal measures. The first line of protection is you and the way you behave. Natural fiber or certified anti-static clothing. Never synthetic fibers in a classified area because they build up a charge. Anti-static safety shoes, suitable gloves, and for liquefied natural gas cryogenic gloves worn in such a way that they can be pulled off instantly if liquid gets inside. Goggles or a face shield. A helmet where there is a risk of falling objects. Hearing protection where it is needed. And then 3 prohibitions that admit no exceptions. No smoking, no naked flames, no use of phones or electronic devices in classified areas. A phone in your pocket, in an ATEX zone, is an ignition source. Now the good operating practice, the heart of this episode. Before you fill, you check. Is this the right receptacle for that gas? Do the markings, the shoulder color, the label and the classification all match? Is the date of the last periodic inspection still valid? Are there dents, cuts, corrosion, deformation, fire damage? Is the valve intact? Is the connection undamaged? If something is not right, it goes to one side and it gets reported. Check the residual pressure. A receptacle that arrives completely empty or under vacuum is a receptacle that may have air inside it. And air inside a hydrogen or propane cylinder means an explosive mixture inside the receptacle. This is why the purging procedure must always be applied. Check the hose and the connections before every hookup. Bulges, exposed metal braiding, worn seals. Those are the points a release starts from. Make sure the equipotential bonds and the earth connection are genuinely connected and not simply resting in place. During filling, open the valves slowly, gradually, never in one snap. Stand to one side, never in front of the connection or in line with it. Look for leaks using leak detection fluid or a detector. At the end of filling, close, depressurize, and purge the line before disconnecting. Check that the valve is tight. Put the cap and the guards back on. Check the labeling. And check the weight wherever filling is done by weight. Let us talk about storage and about how to recognize a non-compliant situation. These are the things that should make you stop and report. Liquefied gas cylinders lying down instead of upright. Receptacles that are not secured, just leaning, able to fall over. Missing caps or valve guards, full and empty mixed together with no separation and no identification. Flammable gases stored next to oxidizing gases, with no distance and no separating wall. Combustible material, packaging, pallets, rags, oil drums in the storage area. Obstructed ventilation, covered grills, blocked openings. Cylinders close to heat sources. Ice or unusual frost on a valve, which often indicates a leak. Signage missing, illegible or wrong. Escape routes obstructed. None of these is a formality. Every one of them has already caused an incident somewhere in our industry. And in an emergency, if you hear a hiss, if a detector goes into alarm, if you see a cloud, the first action is to stop the flow. So close the valve if it can be reached safely. If it cannot be reached safely, then it cannot be reached. Full stop. Then move away. Upwind and uphill if the gas is heavy like propane. Raise the alarm according to the site procedure. Keep others out. If the gas has already caught fire, the rule is counterintuitive, but it is the rule. Do not put out a gas flame if you cannot shut off the source. A leak that has been extinguished but not isolated goes on releasing gas, which accumulates and then reignites, and at that point it explodes. In a flame situation like the one just described, you cool, you contain, you let it burn in a controlled way, and you isolate it upstream. Remember, a hydrogen flame is almost invisible. Never walk in a straight line towards a suspected hydrogen leak. And remember that from a pressure relief device that is discharging, the flame can be more than 10 meters long. On flammable gases, do not use carbon dioxide extinguishers. The discharge generates electrostatic charge. Dry powder is the right choice. And if a receptacle has been engulfed in flames or exposed to severe heat, it stays dangerous afterwards. Do not touch it, do not move it. It has to be isolated, cooled, and assessed. Let us close with just 3 things. The first, flammable gases do not forgive improvisation. The plant operating procedures, the EIGA guidelines, and the SOL group manual contain the essential rules for our safety. The second, earthing, opening valves gradually and checking before filling, are the 3 actions that prevent most of these events, every single time. The third, if something does not convince you, stop. Stopping is never a mistake. Stopping and reporting is exactly what is expected of you.